hey, this thing's a parallelogram. I know that the opposite sides are congruent. Whereas today, if I saw it, I would need both pairs to be marked congruent, such as the stress with the whole both pairs part there means that if I gave you a quadrilateral again, just something like, say, look like that, or even now, this way. Okay, let's say it's like this. If I gave you that shape and I said, look, is that a parallelogram? Okay, if that was the whole question, and I said, is there enough information to prove that this shape right here is a parallelogram? You would have to say no, because that is opposite sides that are congruent, but I know nothing about this side or this side. So I need to know that both pairs of opposite sides are congruent to utilize it. Don't just match it up with one property, one pair thing. So when you write this out, make sure that you have both pairs stressed on there. Okay, because that also applies to the opposite angles. So the opposite sides being parallel or being congruent and the angles being congruent. Again, both pairs is what you're looking for. So I have or after all these because it's a matter of you only need one of these things to happen. Okay, the next thing that would have been on the list, I think yesterday, would have been the consecutive angles. And again, just like the other three things up there, if you're going to do something like the angles next to each other add up to 180, you have to do it for both pairs. So if you had something that was in one corner, you would have to look to each corner next to it and make sure it adds up to 180 there. So for this one to work, you actually need to have 3 angle measures given to you. All right, and then the only, I guess this one works too. The diagonals bisecting each other. Again, that's both pairs because you have the diagonals split. The only thing on this list that's one pair is the very last one. But for that thing to work on that one pair of opposite sides, you have to have both a congruency mark and a parallel mark on them. Example of how that list would be utilized. So again, if I gave you this problem and I said, look, here's your quadrilaterals, so they're all the 4-sided figures. I said, is there enough information? Again, the way you would go through it is you would look at each one separately and see if what's marked on there matches up to one of the things, such as this first one that's up here on the, what was that for you guys, top right? If you looked at it, you would have both pairs of opposite sides involved. Both pairs of opposite sides are marked congruent. Therefore, you can say that that thing is a parallelogram because it's both sides. If one of those pairs was missing, it would be a no. The next one here, those are diagonals. Are these diagonals bisected? Like, are the diagonals both split in half? Yeah, so this would be a yes. What kind of angles are these in there? Like classification, not that they're congruent. I know they're vertical. Is there anything on the list that talks about vertical angles? No, so that's a no. This one right here, this is what I was saying. If you have something where you've got the consecutive angles, and again, for this thing to be a parallelogram, you want these two angles to add up to 180 degrees, which they do, correct? Like 120 plus 60 is 180, yes? Okay. For this whole thing to work where you go consecutive angles are supplementary, you have to also be able to check it in both directions. Like that 60 and 120 add up, so do that. Okay, so as long as both of these directions add up to 180, you're okay. Like if this said like 110 instead, it'd be a no. Right? But if this was a 120, then you could say yes, this thing is a parallelogram because the consecutive angles in both directions are going to add up to 180. Yesterday, where they say, here's a shape, I want this shape to be a parallelogram, figure out what numbers I should put in for x and y so that it will be a parallelogram. You basically do this problem as if I said the shape is a parallelogram. It's the same as what you would have done yesterday. Because in this problem here, the things that I give you are, these are opposite sides, correct? Yeah? Okay? Yeah. All right, and for this thing to be a parallelogram, I want the opposite sides to be congruent to each other. Okay, so I know I can set up like 3x minus 5 equals 2x plus 1. And I got x plus 2 equals 1. All right, well, what do you think I need to do first? Solve first. Solve for x. Using this one, yes?
Yeah.
So if I solve for x here, what do I do first? Or how do I go about it?
Subtract 2x.
Subtract 2x. So that's x minus 5 equals 1. So x is how much?
6.
6. And then once I got that, pop it in there. So now I know what x is. I can plug it in. Hy. All right, so everything that we already have would be opposite sides congruent, which I already have marked. Opposite angles would be incongruent. Would also be a true thing. The additional, add it. So your additional properties for the specific type of parallelogram, the rhombus, would be that the diagonals are perpendicular to each other. So whenever the diagonals are drawn in there, they will create right angles. Okay. And then the other thing will be that the diagonals are going to bisect the opposite angles. So meaning like this diagonal will take this angle and split it in half. Okay, this doesn't work for all parallelograms, just anything that can be classified as a rhombus. And since this angle up here as a whole, these two are congruent angles, all those are equal. So those are equal. So is that. Next one, your rectangle. Okay, gotcha. All right, so rectangle means it's got all 90-degree angles. All of them are equal. Your additional properties here, outside of all the ones we already had, like the opposite sides are still congruent, opposite angles, diagonals still bisect each other, so on. Okay? For this one, you've got the diagonals are congruent to each other. Okay? That'll be it. So like, if I drew in this diagonal and I told you that thing was 10, and I asked you how long the other one would be, it'd be the same measure. In terms of these things bisecting each other, when they bisect each other, that means that since they're congruent, they'll split each other into 4 equal parts. So if I know how long one diagonal is, like if I said this whole thing was 10, these would all now become 5. Okay? All right, so the two diagonals are equal. And again, this is on top of the stuff with the sides that we already had from yesterday. Guys, for this one, you don't need to write anything additional in terms of a property, except for the fact that you have to understand a square is a rhombus, a parallelogram, and a rectangle at the same time. Meaning a square takes in all of the properties that they all have. So a square has all of the properties that we've talked about. So that means that this diagonal here is going to split that angle in half. That's a very important thing. Okay? That's going to come up a lot. So cut these in half because it's a rhombus. All right? It will also make right angles right there because it's a rhombus. And then since a square is technically a rectangle, those diagonals are equal to each other, which means when they bisect, they're split into 4 equal parts. Okay? So square is a rectangle, it is a parallelogram, it's a rhombus all at the same time.
Squares are great. Why can't I have a square?